Okay, so back in 2014, we started work on this dependency insight tool for Netflix, and it's called Astrid. I'm not going to go into the details of Astrid because it's pretty complex. I don't think it's going to add a lot of value. But the main idea behind it is that users can go in and identify which versions of software are deployed where, and they can identify these problematic dependencies and call them from the dependency graph. So one of our primary goals with this tool was kind of empower our users to do this exploratory data analysis from within the UI. And so as we were kind of starting out, we looked at the available landscape of UI patterns out there. And there's basically two. There's kind of this faceted search pattern, and then you can embed some kind of query language in your UI. And so both of these things are kind of deployed all over the place at Netflix. But we felt like for the kinds of things we wanted our users to do, neither of them was really sufficient. And so we decided to go with this kind of interactive data visualization instead. And so when I say interactive data visualization, I'm talking kind of specifically about this use case where we're replacing faceted search. And so just to be clear what that looks like, I've made this example here. I'm using, white. I don't know how to use. Oh, never mind. Keynote just quit unexpectedly. Hang on a second. Let's try this again. I don't want to create a new presentation. Okay. Oops. Sorry about this. And let's try it again. Make sure this works. Okay, great. And so to be clear what this looks like, I've made this made-up example. I'm using Anderson's iris data set. So if you're not aware of this data set, it's one of the more kind of famous machine learning data sets. And it's these measurements that are collected from 150 different flowers. And it includes their petal length, their petal width, their sepal length, and their sepal width. I had to actually call my grandmother to figure out how to pronounce the word sepal. I don't know what it is. But that's our data. So I created these 4 histograms to kind of show you how these different measures are distributed around this data set. And as you can see, I think, okay, thank God. When I select various portions of the histogram, I am filtering out the flowers to include only those flowers with the selected traits. And so if you saw Ethan's cross-filter presentation, this is basically the same idea. And so in this way, I'm sort of selectively exploring the data by removing the cases that I don't care about. And so this is our starting point. But as we proceed, we'll kind of see there's even more complexity we can add. And so we can compare this to a more traditional faceted search. And so the look of this UI is very, very different. But functionally, it's similar, right? So this is from Zappos.com, obviously. I'm sure you've all seen something like this. And I have this result set I'm interested in here. And on the left-hand side, I have the facets that I can use to filter it. So in this case, they are product type, gender, brand, price, et cetera. And so the user kind of refines their query by going through and clicking these links or checking or unchecking these checkboxes. And so it's worth noting that, like this previous example, we are actually displaying the data here. So next to each facet is a count, right? But this is a much less kind of rich display of information. And so, arguably in the case of online shopping, where our users' needs are pretty simple, that's like a perfectly reasonable solution, right? Like I might want to have this nice data visualization here. But users don't come in with these complex queries. They come in and they want shoes. So if our users' needs are just a little more complex, we might be able to add some value by putting in visualizations. And so to make this kind of thought experiment complete, if I replace this brand facet from the previous example with a data visualization, you can see what the advantages are. So for starters, the differences in magnitudes between these things are a lot more clear. And so for our use cases at Netflix, where like our result set might be 250,000, 500,000 items, the difference in magnitude actually is a lot more important than the exact number. So in particular, outliers really stand out. And this is important because in our use case, outliers can actually suggest useful queries to our users. So second, we can enable our users to make these kind of complex queries. So here I'm selecting everything that's from Adidas, right? And this is very easy to do here and a little bit harder to do in faceted search. Finally, I can provide custom visualizations for different data types. So if I had continuous data, I could represent that as an area plot. I'm not going to go into area plots today, but a lot of these techniques should carry over. So anyway, that's our motivation, and hopefully I've sort of convinced you this is a good idea. I'm going to, for the rest of the talk, kind of focus on how we implemented this, and I'm going to touch on kind of things we learned what to do and learn not to do. I'm going to put up a bunch of code. I'm not kind of brave enough to do live coding, so I'm just going to talk at you instead. And I expect that you kind of know the basics of React and D3, and you've seen ES6. A lot of this is going to be kind of design patterns, so I don't think it's important to be able to pick up on every kind of micro detail. But first, I kind of want to touch on terminology. So when we talk about a histogram, what we're really talking about is like taking continuous data and binning in, aggregating it, and turning it into discrete data. Right? And so just to be concrete about this, if I go back to the iris data set, I can take these flowers and group them together by their petal widths, which could look like this. Right? And so as you can see, like I've grouped all the flowers of petals of width 0.1 together, and all the flowers of petals of width 0.2 together. And so it's important to note this is like one possible aggregation I can make over this data. There's others. But the important thing is that the input of the histogram is continuous data, and the output is discrete data. It's not a picture. A bar chart, on the other hand, is a picture of discrete data. And so if I think of data visualization as a pipeline, I'd kind of pipe my continuous data into a histogram. I would get discrete data out, and then I would pipe that into the bar chart. And if I just had discrete data, I would represent it with a bar chart. And so as advertised, this is a pedantic distinction. But the nice thing about separating these out conceptually is that we're not tied to any particular representation. So we could represent our histogram with a line. We could swap out our histogram for a different density estimation tool. And so apologies if this is sort of already obvious to you, but it has some implications for how we design components. So with that out of the way, let's talk about D3. So for a lot of us, myself included, we hear the words data visualization and we think like, okay, it's time to break out the D3. And if your goal is to kind of generate a one-off data visualization, D3 is probably still, to this day, your go-to choice, which I think is a real kind of testament to how well it was designed and implemented. But that's not really our goal here. We're instead creating these like coordinated interactive data visualizations, and D3 doesn't really give us any tools for this. And in fact, if we're using it with React, it can kind of make our application a lot harder to reason about. And so just to understand what that means, like here's this strawman component. And this renders just fine. Like the render method of this component gives the DOM node over to D3. I've kind of elided the rest of the D3 code. But you can put any D3 code in here, and it'll just kind of work, right? And if this is like a static visualization within a static UI, like this is a really good solution. But when this becomes interactive, anyone who's kind of worked with React for a little while recognizes that every time this component renders, all this D3 stuff is going to happen again. And so we could solve this problem by bootstrapping D3 in our component.mount mount method, and then we could update D3 in our component will update method. But now we're stuck with this problem of like coordinating between our React component and our D3 code. And as our component becomes more complex, this coordination kind of proves challenging. And it leads to this state where you're kind of wanting more and more life cycle hooks, or inventing them yourself, which is something that we did and then backed away from. And so in general, when you're writing a web application, React, Angular, Ember, whatever, you really want your framework to be the intermediary between you and the DOM. And so this is kind of like especially true in React, because the view diffing means that you have some other code changing the DOM, you cause React to lose track of it. And so using React and D3 together like this is kind of this anti-pattern. It seems like things would be a lot better if we could just have React render our component. And so it turns out that we can do this. And we still get to use quite a bit of D3. So in practical terms, what does that mean? It means you can still use scales. It means you can still use colors. It means you can still use layouts. You can use a collection API. And the layouts is particularly useful because the D3 histogram layout is nothing more than this transformation that takes continuous data as input and returns discrete data. And so it's not tied to any graphical representation. So thus, you can take the output of your D3 histogram layout and pipe it into your React component. And so here's what that would look like. So here I have this histogram component, which sets up the SVG context. And it calls the D3 histogram layout. And then it maps over the result and puts this into individual SVG rects. And I'm taking a few kind of creative liberties with how rect actually works. This isn't technically correct. But the result would be basically the same here. And so it's really easy to see how React's kind of declarative syntax makes this elegant. I'd argue that it's probably clearer than the D3 only implementation. And I want to make a side note here that this is actually the correct way to write JSX. So we have each of our properties gets its own line, and we're going to end up with these really, really nice diffs at the end. And so what we've seen so far is that we allow D3 to handle the math and data transformations and React to do the DOM rendering. The two of them can work together pretty well. But all we've sort of managed to do is take the functionality of D3 and replicate it within React. And so React might not be the greatest visualization platform in the world, but as a framework for managing the DOM, it gives us a lot more power than D3 out of the box because it's compositional. And so we can get this high-level declarative syntax when we want it, and then fine-grained control when we need it. And so let's dive into that. So normally when we're talking about composition in React, what we're talking about is this kind of opaque composition where we build up our component out of other components and we encapsulate them in that component. And so here, when I render parent, I don't have direct access to the child components. Right? And so we can take advantage of this if we just do the same thing we previously did, but instead of rendering a rect, we render this hypothetical bar component, which will do the actual work of rendering rectangles or whatever to the screen. And so the nice thing about doing this is then we can reuse these low-level components across visualization contexts. So we could use the same bar in stacked bar or tree map or whatever. And I do want to point out that I mean bar here as in bar chart, not as in foo bar. I did these slides, and then I realized that was probably the worst choice I could have made, so bear with me. And so because we don't have access to direct access to our child components, it's often useful to kind of expose properties from the child through the parent. And in a lot of cases, this is a totally valid React pattern. Right? But it's not without problems. When the parent component grows in complexity or becomes part of some grandparent component, propagating these properties through the child becomes kind of unwieldy and results in a lot of kind of coupling between our components. And sometimes we need a lot more fine-grained control over these children than this pattern kind of allows us to have. And so to make this kind of concrete, here we have an actual histogram from an early version of Astrid. And as you can see, there's this total of 9 properties that we've specified, everything from kind of the display of the x-axis to the color of the bars. And even with such this large number of properties specified, we still don't have kind of fine-grained control over this component, right? We've already sort of said that a bar chart is the graphical representation of the histogram, and so but we've implicitly kind of coupled them together here. What if I want to represent my histogram as a set of checkboxes? In order to do this, I actually need to dive into the histogram component and change how it works. And that's kind of unsatisfying. So we can see that as more and more functionality gets baked into this thing, the number of parameters grows, and the complexity required to handle it kind of grows without bound. So how can we do better? So first, I should mention that we're making this mistake where we're specifying stuff in here that clearly should be specified with CSS. I did not get blamed this code. I'm not taking responsibility for it. But in general, CSS doesn't really solve this problem. It gives us some kind of control over appearance, but basically no control over behavior. But if instead we created the parent component without kind of specifying the child components and allowed them to be specified later, right, we get a lot more flexibility around appearance and behavior at the cost of some additional complexity and usage. And this seems like it would be a really great way to reduce coupling, but it's not always clear how to accomplish this pattern in React. It seems like every library has kind of a different spin on what the right way to do this. And so in the spirit of N+1, I'm going to spend the next couple of slides giving you mine. So let's start with this. Something like this feels pretty natural, right? Just by virtue of layout, we've kind of expressed the constraints of histogram and bar chart. We understand that a histogram kind of feeds its data into the bar chart. And that's kind of nice. But as nice as it is to read, it's a lot messier on the implementation side. So to begin with, this bar chart component is already instantiated. So by default, the histogram can do very little besides decide where to put it in the DOM. And that's not very satisfying. So we can use React.clone element to create new instantiations of bar chart and add some properties to it. That could work. In React 0.14, we can take advantage of contexts. So I can use the context interface to propagate data to bar chart. This feature is undocumented. I feel like it's undocumented for a reason. So I'm going to kind of rule that one out. And then the semantics get really confusing when I'm putting in a child that I really want to do something fancy with. So clearly, if I know bar to be the actual representation of our data points, I want to kind of make multiple copies of this thing. And so this way I've written it here is not semantically straightforward at all. And so there are a lot of other problems with this. If I want to add a second child to the bar chart, how is it to differentiate between bar and its other child? And so an alternative is just to provide an uninstantiated bar component as a prop on bar chart. And so in the render method of bar, we just kind of take this.props.bar, we add a property to it, and we wrap it in JSX, and then we're done. And so this reads really well. It's probably a little bit better than the previous attempt. But we're a lot more limited, right? So previously, we had this instantiated component. We could add properties to it outside of bar chart. But the only place we can add properties here is within this bar chart render method. And so a popular solution that you'll see a lot is to have a function that takes in some value and then returns an instantiated component. And that's OK. I'm not in love with this because we don't really record anywhere what this datum variable is supposed to look like. And so a better solution might be we create this wrapper component bar2, and what it does is it just renders bar. And so it's worth noting that this is basically the same thing as this. Here we have an anonymous function, and here we have a wrapper component, and they do the same thing. The difference is that because I have this wrapper component, I get to take advantage of React features using it. Right? So in specific, I can take advantage of lifecycle hooks. I could do prop type validation. And in general, the contract between between bar chart and bar2 is a lot more explicit. And so finally, if we use this pattern, we get to actually have a default implementation of bar. Right? And that way, I can just add a bar chart to my application, and it just works. And it's only in the case where I really want to have fine-grained control over how bar works that I have to specify a custom component. And so to clarify what we've accomplished here, we can be as granular as we want with the specification of our components. We could just use this simple histogram component, and it returns a bar chart. Or we could go crazy and have a completely different kind of representation of this data. So how about representing your histogram as checkboxes? So now we can actually add the faceted search style back to our application if we want to use the same histogram component. So I'm not necessarily advocating that we do this, but the nice thing that I'm pointing out is that we haven't tied ourselves to a particular representation. So we started out by just kind of translating our D3 code over into React code, but it turns out that if we leverage React's compositional capabilities, we can actually do a bit better than that. We create this high-level declarative code without kind of sacrificing our ability to be explicit. And so the important thing about this is we can take advantage of this to make up for some missing features. And so when I say missing features, what do I mean? So there are a few things, notably axes and brushes, that are in D3 that we'd like to use, but they don't really fit that well into our model. And so if we start by talking about D3's axes, the axis component is tightly tied to its SVG implementation. And so for a continuous data representation like an area chart or whatever, you might want to write your own axis component. But for our case, we're just rendering histograms. And so we already have this kind of well-defined way of iterating over our data and defining the behavior and appearance of that data. So perhaps the correct solution is not to use an axis at all, but to make the representation of the X label the purview of the bar components themselves. And so here's what that would look like. This is a very kind of simple case. And what I'm doing here is I'm just adding a text element to our bar component. And so this idea was initially suggested by a colleague of mine, and at the time I was sort of so indoctrinated with this traditional model of data plotting, having used D3 for a long time, and ggplot2 and matplotlib before that, that I was very resistant. But I was convinced of the correctness of this approach for a couple of reasons. One is that we iterate over the data a single time, and we're able to generate both the rectangle that draws the data point as well as the label. And then the second one is that we can become kind of arbitrarily sophisticated in how we want to draw our labels. So if I go back to kind of the faceted search example, if I want to represent all the Adidas brands with one color and all of the other things with another color, I can do that here, but some generic x-axis component isn't really going to give me that flexibility. And so this covers the x-axis only. If you want to do a y-axis, you're going to have to do your own. We, as I said before, we're kind of more interested in the difference of magnitudes. So we don't have y-axes. Yep. And so that's axes, excuse me. But there is one more D3 component I'd like to use, but we can't, and that's the brush. And so if you're not aware, D3 comes with this tool called the brush, which is the thing you'd actually use to interact with your components. and it kind of looks like this. And this is just an example I grabbed from the web. And so like the axis, the brush is actually tightly tied to its implementation, and especially because it's kind of this interactive component, we'd have a really hard time using it from within React. But if we recall that our purpose in making this visualization is to replace a faceted search implementation, this means that at a minimum, we should be able to do all the things that faceted search can do. So basic interactions like clicking on a bar to make that selection are possible with this, but they're not free. We kind of have to resize the brush to the bounds of the bar, and we have to write that code ourselves. And a lot of the more advanced tricks of this, like these 2D selections, are actually not going to be helpful for our users. And more importantly, what if our users want to select multiple ranges at the same time? This is something that they can easily do with a faceted search interface, but you can't do with the brush. But if I create a custom interaction, I can replicate this functionality easily. And so here I'm showing the selection of multiple ranges. And so I guess what I'm arguing is that our users' interactions are so core to what we're doing that we can't actually get away with using a general purpose tool like the brush. And so losing it here is not a big deal. And so what can we do instead? So for a histogram like ours, we basically do the same thing that we did for axes. We just add event handlers to our bar components. And that kind of looks like this. So I've got these two different event listeners attached to the single method here that removes or adds the current value from the active selection. And elsewhere, I have a second listener for mouse up that finalizes the selection and triggers the redraw of the application. And so I really like this approach for the same reason that I like to put the X label here, and that is the individual components have total control over whether or not they belong to the selection. And so we can compose our visualizations this way without kind of rebuilding everything from scratch. That said, I will say that the one area where D3 kind of beats this out of the box is in performance. And that's because the brush is a single element, and this is going to be 20, 30, 40, 50 elements with their own event listeners. I'd say in practice, we're able to get 30 frames per second with 50 elements in your bar chart. If you need more than that, you might want a different representation anyway. And so once you've designed your components, you still need to coordinate them. So selections I've made on one component need to be propagated to the rest of the application. And unfortunately, React is kind of not a panacea. In our first version of Astrid, which we wrote in straight React, I would say like 90% of the bugs that we introduced were these kind of state synchronization problems where some state in some part of the app wasn't correctly propagated to all the components that cared about it. And so we ended up with like resulting DOM out of sync. And so here's where I'm going to kind of punt and say that the right way to kind of solve this problem is to use one of these application architecture libraries. The Flux pattern is very popular. I don't have an opinion about which one is best and why. I can tell you that we are moving towards the OM model, where you have this single global data structure that represents all the state of your app, and every time that data structure is updated, your entire component tree re-renders. So specifically, we're using the imstruct library, if anybody's aware of that. My only caveat is that I haven't gotten it to be performant with the size of the data set that we are currently using. I think I will be able to, but I'm not entirely sure. OK. And so now we're going to move into the part of the talk where I expose some of the goofy shit that we've tried. And so the first of these is kind of making composition easier with SVG. And so the problem is that our SVG canvas origin is at the top left. But the drawing that we want to make starts at the bottom and works its way up. And this means we actually kind of need to propagate two pieces of data throughout our visualization, the height of the element that we want to draw and then the height of the container itself. And this is really unsatisfying. And so back in the old days when we were creating these one-off data visualizations with D3, this wasn't really too big of a deal, right? We had some math that handled it. But if we want these composable components, we either have to pass these two values around or we have to do some other fancy tricks. It feels like it would be a lot nicer if we could just draw our shapes with the origin at the bottom left. And so we can do this. We can just draw our component upside down and then flip it over with CSS, and we eliminate a whole bunch of math. And here's what that looks like. So keen observers will notice that there is this kind of slight problem that we could solve by, like iterating over our text elements and rotating them again. That's like a reasonable solution. We don't want to introduce kind of more problems than we're solving. So one way, if we're willing to get even a bit more creative that we could solve this, is we could just use an upside-down font. So this kind of seems crazy. It's not necessarily as unreasonable as a trade-off if you want to pay this kind of like small upfront cost to have an upside-down font, and now your visualizations are just that much more easy to reason about. I'm not advocating anybody do this in practice. I will remain silent on whether or not this is actually how we accomplish this. Well, it's only flipping this way, right? OK. Testing. So I think this is probably the most kind of overlooked or ignored aspect of implementing data visualizations. And so for years, I kind of did all this stuff without writing tests of any kind, simply because it was just like way too hard to write a meaningful test about a data visualization. And so then React comes along, and like the great thing about React is it allows you to write unit tests for things you'd previously test under the guise of like end-to-end or integration testing. Right? You can instantiate these components from a known set of inputs. You can simulate mouse events, and it's great. It's really like one of the original reasons that I wanted to write data visualizations with React. But it turns out that it's not kind of all wine and roses, right? The output of your React component is still a DOM element. And if you want to test it, you're still kind of making the same DOM assertions that you would make under an end-to-end or integration test. And so we've improved this test setup. We have this nice declarative way to like instantiate a component, but we haven't fundamentally changed the things that we're able to test. And so we might be able to squeak by with assertions like, well, I expect there to be 10 rect elements in this bar chart. But in general, the structure of the DOM is completely irrelevant to the thing we're trying to test. Like fundamentally, what we're doing here is we're taking data and we're transforming it into pictures. So it kind of seems like what we should be testing is pictures. And so this kind of testing is sometimes done as visual regression testing. And unfortunately, unit test frameworks aren't really designed to allow you to do this. So I spent some time trying to come up with a way to do this during our unit tests. And so before we get into that, let's understand how testing with React is sort of different than end-to-end integration tests. When we use React test utils render into document method, React is doing literally everything except what it says it's going to do. So it instantiates the element, but it never actually puts it into the document. And this way, we can interact with it. We can simulate mouse clicks. We can make assertions. But then when our test is complete, our element falls out of scope, and presumably it's garbage collected. And so if we contrast this with like end-to-end tests, the item under test is an entire DOM tree. So if we want to obtain isolation, we need to create an entirely new DOM tree, presumably by navigating to a different page. And so like this seems nice. We want to kind of do things the React way. This is a really nice way for us to declaratively have instantiated components and have test isolation. But unfortunately, because the items aren't actually put into the DOM, that doesn't make it really that easy for us to take pictures of them. And so to get around this, what I do is I serialize the SVG to a string. I encode it in base 64. I convert it to a data URL, load it as an image, render it to a canvas. I export that canvas as a second data URL, which then I compare to a known good result using an image comparison tool. Okay, so I hope everybody got that. So I'm intentionally kind of not throwing the details up on the slide because it's kind of a gross hack, and I'm not convinced it's the best approach. And partly because what I'm talking about here is this idea that instead of making these DOM assertions on our visualizations, we should make image comparisons. And so when we convert an SVG to a raster image, we lose information. And like naively, that seems bad to us. But it seems like the information we lose, the stuff pertaining to the structure of the SVG, is exactly the information we don't care about. And so by removing that from the test, we've actually kind of made the test more robust to certain kinds of change within the component. And so further, we get to write the specification for our component as an image instead of trying to describe it with code. And so we can still, simulate user interactions with our component, render that as an image, and have that be the specification for that test. And so this idea that you would build a thing first and then use the thing you built to test itself kind of goes against the grain of TDD. Right? I get that. But I look at it this way, right? You know what your visualization will look like before you make it. And if you could write that out as a specification, you would. But unfortunately, we kind of lack the tools to do so. And your designer's mock-ups are kind of not appropriate here. So really, we need to create it first so that we can say that it is correct. And so the real value of taking this completed image and kind of adding it to our test suite is, first, we've recorded what it looks like. Anybody can go into our repo, click on the picture, and be like, oh, OK. Right? And second, we prevented code that shouldn't change the UI but somehow does from silently breaking our component later. And so this works. It's not perfect. The workflow that I've created is not super convenient. I kind of tinker around with the component until it looks correct. Then I manually extract a ping, put it in the repo, and then when our test fails, our test runner outputs these 2 data URLs instead of nice pictures. And so, I think this approach has a lot of merit, something that we're just starting to adopt, and I'd love to talk with others about kind of what they're doing and why, in particular, you think this is a bad idea. But if it does turn out to be a good idea, I'd like to kind of develop more of a workflow around it. So that's all I have. I don't have a final slide because I hate goodbyes, but I'm happy to take questions.
The image dipping thing,
Mm-hmm.
does it have some fuzziness?
Yeah. Yeah. So we put it. We hard code in a threshold. Yeah.
There's a couple of existing tools that there's one called CSS Critic and one called Bit.
Mm-hmm.
That both do a similar thing.
OK.
So there is some prior art.
Sure. Yeah. Sure. Oh yeah. Yeah. No, this isn't completely reinvented from scratch. The only thing that we're reinventing from scratch is generating the ping itself from the test suite.
Those folks do that same.
OK. Yeah. OK. I'd be interested to see what that is. Yep.
And I see from your examples that you have still the animation of the bars
Yeah.
going on
Yeah.
in each direction. Are you using then the D3 animation?
No. That's a good question. So these examples, I'm using React Motion, which is it's a Spring simulator, and you have a Spring component, and that feeds interpolated values to your component. It's pretty neat. It's not super fast because it's all kind of happening in JavaScript. I mean, yeah, I like it a lot. Yeah.
Because it looks like one thing that is lost doing it the composed way is the exit action for D3 of D3's ability to reuse
Sure.
things that stay on stage and only move to
And to be clear, we can actually do that with the Spring. Yeah, we can do that. I just haven't done it this way. I have this initial value that's set to 0. Yeah. All right. Thanks.